Thanks, everyone. Please welcome our next speaker, who will be talking about adding a metric to Perfetto for the next pay metric. Cool. Thanks.
Yeah. Oh, okay, it works. Hello, everyone. My name is Patricia. I'm from the Eindhoven University of Technology. And today I'm going to talk how I spent my summer doing the best and making Perfetto perfect by implementing interaction to next pane metric. So just quickly about myself and who I am. I'm from Vilnius, Lithuania. That's why I have a bit of an accent, but hopefully you will be able to understand everything. I moved to Eindhoven to study computer science in the Eindhoven University of Technology. However, algorithms and automata weren't enough for me, so I started doing a bunch of extra things, organizing events for students. And one of the events, Code for Ukraine, was mentioned in Google I/O 2022. But why this Google I/O was so important to me, not only because of this event, but because Chrome Web Metrics team introduced a new metric called INP. And I was lucky to work with it during the entire summer with the team and implementing to Perfetto that I will explain later. This project got me so much into metrics that even during my time at Microsoft, I tried to be involved in performance as much as possible, working in the hackathon, a bit with a sustainability metric, a bit on a drop frames detector with Edge team. And now I'm in Tracing Summit. Thank you for having me, and thank you for giving me opportunity to present my project. So firstly, what is Google Summer of Code that I mentioned? It's a global online mentoring program that focuses on new contributors in open source. All contributors work around 12 plus weeks on the project with their mentors. They code and basically contribute. Previously, it was open only for bachelor's, master's, and PhD students. But now everyone is welcome to contribute either as a mentor or admin or contributor. And my project was INP analysis on Perfetto. I was working with Michael, Ayuan, and Lan. They were my mentors. They're from Chrome Performance team. And I got to know the entire team. They're wonderful people who are dedicating their lives to analyze user experience and make browser and web smoother. But at the same time, big shout out to Hector, the entire Discord team, who were helping me understanding Perfetto code base and doing very first steps with metrics. The goal of this project was to provide more details of INP to developers, analyze other possible ways calculating INP score, and of course, visualizing INP on Perfetto. And my organization was Chromium, where a bunch of admins were helping me as well in succeeding in this project. So moving to the project itself, I will divide my speech into 4 main parts. Firstly, I will explain what is INP and how we can measure responsiveness using INP. Then I will show why metrics were so important in this project, especially Perfetto. And lastly, I will show how to add INP to Perfetto and do some demo. So what is that interaction to next pane, which is so bright on any Twitter performance forums that was introduced in Google I/O? So it's an experimental full page lifecycle metric that assesses responsiveness. It's similar as first input delay, but a bit more complex, and let me explain why. So responsiveness can mean anything, right? I mean, in our context, we have heard responsiveness so many times. But in this context, in web, responsiveness means understanding how fast a web page responds to user input. For example, when I try to open a menu, how long does it take for a web page before it appears to be doing something at all? Good responsiveness means that a page responds quickly to interactions made with it. And here you can see good responsiveness versus poor responsiveness. On the right, long task blocks main thread blocks menu from opening. And user, and I would, think that, well, this menu must be broken. So if we click a bunch of more times, it should work, right? But browser doesn't think in this way. When the main thread catches up and processes all the delayed inputs, it makes menu open and close automatically. That brings to poor responsiveness. And on the left, you can see good responsiveness, visual feedback immediately. Whenever I press, I see all the details I want to see. But it's still pretty abstract, so we need numbers on how actually we can measure. And INP aims to represent overall page responsiveness by measuring all click, tap, and keyboard interactions made with it. Some examples can be clicking with a mouse, tapping on a device with a touch screen, clicking a key on either physical or on-screen keyboard. But you might have noticed something already, that all those events have one main feature. They're all discrete events. And here, the key thing to understand what interaction is. So the group of discrete events, event handlers that fire during the very same logical user gesture is called one interaction. Here we have tab interaction on the right. So it includes pointer up, pointer down, and click. It's very important to know that we include only discrete events in one interaction and omit all continuous events. So we do not take care of drag and scroll to make our lives easier and easily compute INP. So we know that we are measuring interactions, events. So how we can represent interaction timing. Interaction timing consists of three main durations: input delay, processing time, and presentation delay. Input delay is from a time when user actually interacts with a page, clicks, to the time when event handlers are executed. Processing time is the total duration it takes for event handlers to be executed. But here is the trick. We know that we have a bunch of discrete events in one interaction. So we take the longest duration of one discrete event processing time. Here we have pointer up, mouse up, and click. So in this case, we would take just mouse up duration of processing time, and we would say, OK, this is our total processing time of one interaction. And then we have presentation delay. So it's from the time when event handlers are stopped executing to the time when user can actually see presented frame. But INP actually is one score, right? Because we have to assess responsiveness. So we calculate a bunch of interaction timings, and we take only the largest one. We say that web page is responsive if it's below 200 milliseconds. If INP score duration of the longest interaction timing is between 200 and 500 milliseconds, we say that the web page needs improvement. And if it's above 500 milliseconds, we say, well, web page does poor in responsiveness. But here is the issue. Developers work hours, weeks, and months and years on developing websites. And they get one single score saying, hey, could you improve the responsiveness? So what are they supposed to do? And with Perfetto, we can do way more than just one INP score. We can get the entire set of interaction timings. So I'm not going to explain what Perfetto is, because I feel that most of you have used Perfetto way more than I did. But the way it worked is I traced a bunch of web pages with DevTools timeline, Checkmark, and then it gave me event timings, timeline, and all sorts of data of event timings, where I could query everything about the event timing from a consistent set of tables. Consistent set of tables is just SQL tables. I mainly worked with event tables and especially slice, where I could get all sorts of information about the specific event, duration, timestamp. But for each event and each slice, I could get even more. I could get arguments. So I could get interaction ID. So it's a unique ID that identifies interaction that event belongs to. Processing start and processing end. So beginning and the end of event handler's execution timestamps. This is, very briefly, it's just SQL querying all necessary data about the event from the slice table, where the name is event timing. I got the timestamp, processing start, interaction ID, everything that was needed. And even I could track down the process where the event occurred and the exact web page. And here I calculate INP. The very main thing the main issue that many interactions can occur in the same frame. So if we aggregate and group by end timestamp, then we can get all the interactions per frame and calculate INP per frame. So, of course, Perfetto UI is a wonderful tool in the beginning when you want to just quickly write a SQL query. But I used Google Collab, and it gave me freedom to use Python and analyze INP the way I wanted. So give me a second. Could we switch to, yeah. So in the very beginning, we installed Perfetto, trace processor. This is the exactly same code that I just showed. Query all the slices events, calculate INP, get the interactions interactions per frame. And then this is the very first visualization of INP that was ever done. And this was wonderful because it was already a lot. Well, the code, I just shortened it a bit. The code was way longer, but this is the final result. However, the issue was that in Google Colab, well, it's wonderful, but nobody could see it besides me, my mentors, and a few other folks. So the main goal is to actually visualize it on Perfetto. Could we switch quickly? OK, thank you. So it's very simple. We firstly create a proto saying what should be visualized in the metric and what data we would like to see on Perfetto. Then we adjust SQL a bit and say, OK, could you put this data in proto and display such things that we want to see? Very basic things, timestamp, durations. The key thing are all events that we can even see how many interactions and what type of interactions occurred per frame. And lastly, we even calculate input delay, processing time and presentation delay, percentage of each event timing. And what we get is a wonderful thing where we can see all the basics information, but at the same time we can see the type is a mouse down and pointer down. We can see the percentage it took for input delay, processing time, and presentation delay. And why this is so important, because for a very long time, everyone thought that input delay and presentation delay were the main issues. But here you can see if it is true. You can actually see how long it took, what's the percentage of the processing time, and take into account processing time as much as possible. So we have already a metric there, but we would like to see, of course, a timeline. It's a bit trickier than a metric, but we also did it, and the way we did, we only visualized the largest duration of the event timing, as including input delay, processing time, and presentation delay. And for all others, we visualized only timestamps, just to see more data and not to avoid overlaps. So here we, as well, adjust SQL file, add metric to UI, and then run. And give me a second. Can we switch? And here we have INP metric that says good or needs improvement. And if it's good, so as I mentioned by the definition, it's below 200 milliseconds. If it needs improvement, then it's above 200 milliseconds. Then we have a bunch of timestamps, and this is our longest interaction timing that actually developer can see where is the longest and what was below it, and maybe do some additional research on how to improve responsiveness. So it's way more than just one score that is just provided to the developer. Could we switch? And this was in case of demo it doesn't work. But of course this project, as almost all projects, isn't without improvements. And the main question right now about INP, how to visualize it in a smart way. Because timestamps also can be a bit misleading, difficult to read, and as everything in tracing, it needs some logical way to visualize. So the perfect way to visualizing would be visualize all interaction timings with input delay, processing time, and presentation delay, and even say what kind of interactions occurred in the very same frame. Then, of course, add multiple ways of measuring INP and analyze it a bit more, because there are also other theories. Taking maximum as a processing time might be not the best way. It is the way it is right now, but we could investigate taking gaps and islands and basically other ways of analyzing processing time. And lastly, adding more metrics, because metrics are amazing when you have a bunch of data and you just see one metric, and you can immediately say what's wrong and go dive deeper based on the metric. And of course, this project actually was very fun to me. Hopefully, I will see more people working on Google Summer of Code, on Perfetto, and implementing metrics. And if you have any ideas, any suggestions on metrics that you would like to see on Perfetto, let me know, and I would be happy to work on that. And thank you. Any questions?
Cool. Thanks, Patricia. I think there's a question here. Yeah, there should be a microphone at each end.
That was an absolutely fabulous presentation. I wish I knew what you did to make the slides. It's amazing looking. But there was one thing that had me going, which is that continuous events, in particular scroll, are ignored. And it occurred to me that obviously dealing with it as a continuous event would be a nightmare, but you could possibly turn it into a stream of discrete events by asking what the gap is between the time a scroll was requested by the user and the time each individual element appeared on the screen so it could be interacted with or disappeared with. This would at least let you spot cases like I dragged the scroll bar and nothing happened for 10 seconds.
This is a good question. Continuous events, basically the INP is still experimental and it's still in labs, and people are working on that and seeing the way to improve it. But by the definition, I got the definition, didn't go much into detail of continuous events, but by the definition, only discrete events, and they mainly said that it's a bit difficult to actually measure and get the best measurement of continuous events.
I was thinking you could discretize them.
Good way, but it could be an option. I could talk to my mentors and say, hey, maybe continuous events as well. Okay.
Things that aren't measured get ignored, and I don't think we should ignore scrolling time.
Of course.
Some little more context. I think that the challenge there is that when you do touch event, when you do touch scrolling, the code paths that you hit and the entire composite architecture is like quite different than dealing with input events. So like from a user perspective, yes, makes a lot of sense. From a technical perspective, it's a completely different problem, because then you get in the state where you try to do like directly compositor side scrolling, where you just tell the GPU to just move some layers around, but sometimes you fail because there is some JavaScript handler and you need to fall back. But then the sort of things that you need to deal with they're very different than the case where you do like discrete events, because they hit completely different paths. So like would be an entirely different project. Yes, makes a lot of sense, but would be a completely different like set of metrics and a completely different project. Oh yeah. And from the end user perspective, it would be real if it looked the same, but would be like very, very different project. Congratulations. I echo the congratulations for the presentation. That was like really, really awesome.
Cool. Any more questions? Oh yeah, I think we've got one at the back.
Well, I have a question, but I also wanted to add a little bit. We have actually looked at scrolling sort of metrics internally, but as Primiano said, the architecture is very different. And so exposing that to web developers is a bit harder because it often comes down to a Chrome problem and not so much a web developer problem. And so the metric doesn't necessarily have as much use. I wanted to ask, you ended up using timelines like with instant events to sort of show, did you look at expanding that or adding other metrics to sort of get the tiering? I know event latency has this sort of breakdown. I think you use derived events, which I don't support tiered events, but have you looked at other ways to sort of display this in that tiered way that you were mentioning?
Yeah, so ideal it would be just event latency showing and having the stack. However, as a metric to visualize, it's a bit predefined and we can't. But hopefully I will get to the stack and visualize all the interaction timings, stacking on each other because it would be way easier. But so far, yeah, I would aim in the future to get this stack and visualize as event latencies, and that's right.
Cool. Thanks so much. And also really glad to see you present here at the GSLAC.
Perfetto is an internal Google tool. So I'm wondering, do we plan to use this as a for Chrome developers to improve the Chrome feature, or is it intended for web page developers to improve their page development?
Good question. I think Perfetto folks can answer about the future. I don't know.
Okay, fair enough. So, well, Perfetto is open source. Like the main target of Perfetto is Chrome developers. But it's a bit the same situation of Perfetto for Android and then Perfetto being amended by Android Studio. Some of the developers' tools are internally based on top of Perfetto. Some part of the Chrome DevTools timeline is actually based on Perfetto. So what happens is that most web developers don't even know that they're using Perfetto, but they use other tools that are more tuned for web developers, and they use Perfetto indirectly, and they use a subset of that. Some power users like that, there is a set of users, I cannot name companies, but there are a set of big users that tend to know very well how Chrome works, sometimes even better than us, and then they want to look at the full details, and they tend to use Perfetto to develop web properties.
Thank you. Wonderful.
Thank you.
Cool. Any more questions? Okay, in that case, thanks, Patricia.